you have to specify a different, you have to specify the environment which you are using. I'll show you once. First for the this one, Jupyter, and then I'll go for code. Are you all installing? See, in Anaconda Navigator, we get two options. One is base and one is TensorFlow GPU. So I can set to this. Say for the people who will be using Jupyter Notebook, they have to use this environment and then reinstall Notebook. You can use Spider, but like if you want to use Spider, then I would say why not go for Code, Visual Studio Code. Which one, Spider? So you have never used Visual Studio Code, right? Okay, okay. So you are basically used to the environment, isn't it? No, why I am saying Visual Studio Code, because nowadays when you install Anaconda, once the installation is over, is it over? No, why I'm saying this, because now like Anaconda team, they have collaborated with Microsoft to suggest you to install Visual Studio Code. It is- Yeah, so one of my online students, so student number 23, he's asking, what is the difference between tip and conda? So you must be knowing it, isn't it? Yeah. Huh? So for the online students, I'm saying conda install or conda activate is mostly used for the commands which applies to only Anaconda, and pip is mostly used for the normal Python installation, which does not require Anaconda. Next question which I'm getting is which we should install, cloud-based or R supported? Student number 36, what do you mean by cloud-based or R supported? Install cloud-based or R supported? You need to install Anaconda. In Google Colab. Python. You can listen. Can you share link? Google Colab Python and Google Colab Python. You can compile online. Google Colab Python. Yeah. Link of what? What link do you want? Okay, fine. Don't call me sir, by the way. Don't call me sir, by the way. So as I was saying, in this TensorFlow environment of Jupyter, um, we can launch it. So if we don't use this environment, then we cannot use the TensorFlow codes. The advantage of TensorFlow is since it's a machine learning library, so everything would be say because it's since it's machine learning, so everything can be segmented like like segmented like by layers or say groups, but which is not supported by normal Python. So you create one, show you here. See, I have this code of TensorFlow. So Jupyter, one advantage of using Jupyter is that you can run sections of code separately. But for our purpose, we won't be using Jupyter. We will directly go for Visual Studio Code. So it's suggesting that Matplotlib is not installed, so we have to install it. Okay, okay. That's it. Thank you, sir. Wait. So I guess now it's working now. So we will set up Visual Studio Code folders. D drive. Take for example, we were taking this code, but right now we cannot run it. Okay. Code run. Okay, I'll be installing this one. No, I know how to run, but I'm still. No, I know exactly how to run, but still, I prefer this one sometimes. Yeah, code run. It turns out to be handy sometimes. So I just have the code, but I don't have the environment to run it. So what I'll be doing, I'll type Control Shift P. Wait. I made a mistake. Uh, I'll add configuration. That would be, yeah. So since we have selected, say, uh, Python file, and then we go to debug and open or add configuration, it automatically sets an environment for Python, launch.json, debug, and then add or open configuration. No, first you have to create a Python file, .py. Did you? Did you create? No, you can create one blank one because we will be running TensorFlow codes, right? So just go to debug and add or open configuration. So one environment will be created. So now our file is ready to run as a Python file, but see, we are not. This is not able to import TensorFlow because if you go down and see, it is still using Python 3.7. So I'll select TensorFlow GPU. Okay. You can also use a shortcut Control Shift T and say Python packages. Version. I forget. You can directly select from here. So at this moment I'm using TensorFlow. So when I've selected TensorFlow, this error line went out. Okay. So it is ready to run using TensorFlow. So if I here, yeah, just click here and select. No, you need not even install Keras manually because nowadays Keras is an inbuilt library of TensorFlow. Initially, it used to be a different library because Keras is for deep learning and TensorFlow is neural. Keras is basically neural network, and this is pure machine learning. So now it has Keras has been embedded to TensorFlow. So I'll even make a change here since it is written as Keras dot. If you see over here, I'll make it to TF. Dot. Just so basically in TensorFlow, for you can predict, like for machine learning, what do we get? We train and then we predict, isn't it? There are 5 steps. One is, say, collect a data set. Say this is collecting the data set. Okay. Then building a model. This one is not building. Yeah, this one is building the model. This is training the model. This is, say, collecting and then building the model. Okay. Then this is training, and evaluation and also prediction. There are 2 more steps, but in this program I'll be just showing one of the say data. Okay. Usually it happens in 5 steps. One is, first is collecting, then building model, then training, then evaluate, then prediction. Okay. So it is downloading the data set from the specified link. Say these Karis.data set, it has a list of data sets. Okay. So every time you run this code, it will download from online, unless and until you have saved it on your machine. So this is basically the link. So even people who are more familiar with R, you will get to know that you can also like pull data sets from online, their libraries, isn't it? So they have GitHub libraries, and once you give the instruction, it will pull from that library. So this is the output. Say I have turned this into binary. If in case I don't turn this into binary, then it will be in colors, I suppose. Uh, uh-huh. Yes. So this, okay. Uh, So what you first get is the image. It's not in say grayscale. And our next method is to normalize within yeah. So our next method is to normalize the image. Okay, just a portion of it. And here is the normalized version. If you can see, initially it used to be fully yellow, isn't it? Now after normalizing, it became turquoise, or say green blue color. So this was just the first demo of using TensorFlow. Okay, now I'll go for a proper code where I'll be discussing these steps which I have mentioned. If you want, you can I can give you this code. Okay. So in this example, I'll be showing you a demonstration of using say TensorFlow, like a better example. So just like we had used this MNIST library previously, here we'll be using fashion library, which has different data sets of addresses. Okay. So after we collect the data set, we store in this function, and then we will train and test. So while training and testing, we also need to add labels. Okay. So where we will place labels here, and we will segregate the images into these many classes. So when we view or visualize the image, each image will be tagged using say trouser or t-shirt. So these will be the class names. So in neural network, we get to see that it has to be the processing has to be done in layers, as I taught you, and I have also mentioned about deep neural network, isn't it? So if you can remember, I told you that minimum layers has to be 3, more than 3, isn't it? It was more than 3, if I am not mistaken. Yeah, deep. It was more than 3, isn't it? So here, say these are the layers. Okay, if you these are the layers. So if I just copy and add one more layer, it becomes a deep neural network. Okay, and if I remove it, it is a normal neural network. So this is one way of adding layers. This is the way of adding layers basically. So like for the activation function, they are using this ReLU function. ReLU function, I guess. I guess it will do in this way. So this is the 0, and here is 1. I guess ReLU does this. Uh, yes, activation function. So in this code, huh? Yes. Like okay, just show you what I. See, isn't it? So it's gradually increasing. It. Say no. Z is this. Okay, this x-axis. You would say. You can say, and this is say phi of z. Okay, y-axis. So when z is greater than 0, it will remain z, and when z is less than 0, it will remain 0. So there, the function won't come down. Okay, either 0 or greater than 0. You get the logic. No, z is this one, x-axis, phi of z. Mm-hmm. 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 Like, you mean to say that behind value? Mm-hmm. Hmm. Mm-hmm. Yeah. No, no, not, no, it is not linear. It is non-linear. Uh-huh. Hmm. Hmm. Mm-hmm. Mm-hmm. Hmm. Mm-hmm. Hmm. Okay, how we come to Z? Say, see, say Z is coming from here. Huh. Yeah, actually, like I was planning to come up with that type of thing, but madam told me to directly give a demonstration of TensorFlow. Huh. You mean for this data set? Derivations I won't be able to give you, but actually I was planning to, or I might even give you one demonstration of. Ha ha ha. In fact, that was I was planning to teach today, but madam told me that she is not very confident about it, so she wanted to give that. Uh-huh. Hmm. Yeah, as I said, like I was actually planning to do that, but madam told me to give TensorFlow. Hmm. Are you from computer science or data science? Okay. So we will first, we have to first set the, for building the model, we would first set up the layers, then compile the model, train the model, and then so basically these are the steps for say first building the model and then compiling, then training and then evaluate. And last is prediction. So as I had discussed previously that TensorFlow can predict data using, or say for machine learning it requires 5 steps. So these are the 5 steps. So for building we require setting up layers and then compiling model, then say train, then evaluate, and the last is prediction. And at first we have discussed about collection of data set. It was done here. So here, as you can see, for these clothes, I'll be displaying the first 25, and even over here, not standardization, but see, I have assigned some class names, isn't it? So we will be putting names on those, labeling. Then we will predict. And for hmm, hmm, hmm. Hmm, hmm, hmm. Hmm. For this one, I don't know. That's why I would like to give my own data set. There, I'll be more confident about it. Hmm, hmm, hmm. So first it is downloading the data set. No, no, not my data set. It is their GitHub. So this Karis library, it has many data sets. Okay, just like I told you in R, you can download the data sets using codes. So even here, you can download some sample data sets for testing. Say this is the first image. So as I have discussed, like displaying the first 25 images of that entire data set is boot, t-shirt, t-shirt top, dress. So you also get all the labels which we have discussed. Now So now it is getting trained. It's in the process of training. And you can see that I have assigned one epoch. Epoch is basically say time frame. So in this time frame, what has been done, in that time frame, what was done. And epoch, there is a standard range. You cannot go beyond, and you cannot stay like it cannot be too less or too high. Yeah, you can say hill climbing in matters of time. If you cross the limit, then it will be say like if you exceed an epoch limit, it will be overfitted, or if you don't reach that limit, it will be underfitted. Okay. Like like the things work only for a particular time frame. Beyond that time frame, that configuration may not be in it, isn't it? That expected result may not be in that time frame, but before it, we may get, say, what we are expecting. It is working only for the first 5 hours. Beyond it may be getting dispersed, isn't it? Hmm. Yeah, for this one, yes, obviously. But since epoch, like we are relating to say time, so I give you an example of time. Hmm. No, even after 5, solution can exist. Okay. But usually what people do, they go till epoch 10, 20 if they have a very large data set, where there is a necessity to analyze in different time frames. Different sections of time. But since we are dealing with only 25 data set, we don't need epoch of 10 or 20. If we hmm. Mhm. Hmm. Come again? Hmm. I understand you. Hmm. 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 Say, see, first of all, for fitting, okay, for fitting, say training, it will train in different sections, right? Hmm. Not it's not segregating in 5 parts. Okay, segregating is different. Say you have segregated the entire data, and say the group which exists in the first, say the elements which exist, or in this case the images which exist in the first section won't be in the second section, isn't it? Here in terms of epoch, everything will exist, all the 25 will exist, but say within the first frame, what is the output? Okay, and then in the second frame, all the 25 will exist. What is the how is it trained? And then in the third phase, how will it be trained? Okay, that's how. Yes, yes, batch run. No, 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 not batch run. Batch run. It won't be actually batch run. Batch run. If you say batch run, then again this segregation thing comes into play. Everything is analyzed, but in different sections. Say all the 25 is behaving or in a different way in this time frame. Okay. Hmm. 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 5 times, not just 5 times, in 5 different time frames. Time frame, you understand, right? In 5 different time frames, or just serial. 5 different serial time frames, and beyond that, you may not get. Sometimes you can get. That's why it is expected that epoch. Yeah, 5 times it will definitely. Hmm. No, I can explain you. Say, no, not relative to this data. Okay, wait. Let me complete this, and otherwise the online students will. So here the model. So in the predictions, it is given, say, um, if it is correctly predicted, it will give green, and if it is wrongly predicted, it will give red. So this one has been predicted as wrong. Again, right. Okay. Then 10, yes. Nine, six, as feature, we have like, Yeah, I'm ending this session.